Okay, y'all, let's talk about the next part of the project. And what we're going to be doing is refining our subbasins. So I need to give you guys a little more specific feedback. I think everyone did a really good job of delineating their watershed, finding those subbasins, and then assigning subbasin models to all of those. Okay. So you have already identified subbasins based on the kind of stream networks, and you've identified major tributaries, you've put subbasins in there, you've created junctions and then connected those junctions with reaches. It's a little counterintuitive to understand like what actually makes a subbasin and how that influences the model, but I think you guys got it pretty well. So I'm gonna take one more look at your models and just make sure we got the subbasins delineated appropriately. And then what you'll do is go back to stream stats and calculate the area of those subbasins. So you'll go find that same junction in the stream network, click on that, and then it'll delineate that watershed. You can bring that shapefile in if it's helpful for you. Again, it's just for visualization. But you'll get the watershed drainage area. You'll get a bunch of different information when you do that model report, like the curve number, which we'll talk about in a little bit. And that'll be input data that you'll parameterize your subbasins with, which we'll get to on the third part of this project. So you'll refine your model, calculate those drainage areas, and I give you some examples here about how to do that in stream stats, just making sure that you're clicking on the right tributary. You got to zoom in so that you're not getting, one watershed versus the other. And then make sure you get the results, the kind of basin data. So select all these different parameters because those will be important. There's going to be a situation where you get down to the bottom of the watershed and you'll have kind of like a little sliver of a watershed here. That is, for me, this is subbasin 3, I think. And it's kind of hard to figure out exactly what this area is. And so you're going to have to basically accumulate all these watersheds and subtract it out from the area of the big watershed to know what this little watershed area is. Because stream stats isn't going to give you a partial watershed, they're going to give you everything upstream, right? So you'll run into that problem. You should be able to get, for example, this one for Canna Creek, since it's so long, I did a kind of mid watershed one. Stream stats would delineate everything upstream. And so you'll just have to subtract these two out to get this area. So I kind of go through that exercise. You could bring all this into ArcGIS if you want to and clip stuff. You don't have to. Again, it's just for visualization. So once you refine and update it, you will go right-click on your basin model, and then you'll resort elements hydrologically. And so what that does is it says, okay, upstream is subbasin 1, and then it basically follows the flow path. I hit junction 1, subbasin 2, junction 2, and then the reaches, right? And so finally at the bottom of this list is my outlet. So that's the hydrologic order. I give you some more instructions about how to connect everything. And once you connect it, you should be able to select an element and drag it, and it'll stay connected. So I can select subbasin 2, and it's connected to junction 1. That's because I could delete this connection, and then I right-click on it, and I could say connect downstream, and then I could use my cursor and do it that way. I could also go in here, click on that subbasin, and then tell it where to connect to, right there. So downstream, what do I connect it to? I connect it to junction, that's subbasin 1, so it goes to junction 1. So you can do it in this option as well. All right, now we're going to get into actually doing the hydrologic model. So to do the hydrologic model, I'm going to go to, sorry, this is meteorologic model. I'm going to go to components, meteorologic model manager. I'm going to do new. And I'll just give it a name. I'll just call it MET1. That's fine. We'll just do that. All right. So I created it. It comes up in my pane right here. Now I'll click on that, and you've got a ton of options. And I tell you in this tutorial, and Jake, I'm recording this so you can look it up later. I want you guys to go read in the manuals and the technical references manuals to understand what is going on here. So I'm going to walk through it really quick though. Let's make this a little bit bigger. If I click on my meteorologic model, I've got some options, a lot of different options. And under precipitation, you'll look at these. I want you to read about them. What are these? What do they mean? I'm going to go to frequency storm. This is the one we're actually going to use. Frequency storm. So then I'll click on frequency storm once I created that. And this is where that kind of meat comes in. I'll have you guys read about these different parameters, but basically you're going to set the storm duration. So one day would be 24 hours. The intensity duration is basically the time chunk. So I'm going to model rainfall at 5-minute intervals, or all the way up to like a 1-hour interval. The intensity position is it going to be symmetric, or are you going to have more rainfall fall in the first 25% or the last 75%, right? Area reduction method, there's only one, and you'll read about what this is. This is basically a curve. And then what's the storm area? Well, we're going to probably, you can play around with that, and I think I give you some directions on that, but usually you want to give it the same area as your watershed. But you can look at why this is important. So I'll just give it a storm area. We'll put that in for now. Okay. That is the basics. You're going to have to look up the actual storm depth and put this information in. So this is going to use the, I can't remember what it's called, but that alternating method to create the Hiatograph. And so what you do is you'll look up the depth for the 1-hour storm, the 2-hour storm, 3-hour, 6-hour, 12-hour, all the way up to 1 day. And that's for a given frequency. So if I'm going to do the 1% AEP storm, I look that up from NOAA, I find that storm depth, and I put all that information in for these different durations. And that creates a storm depth, okay? So that's the basic introduction, and then you can go and read the more details in this document here.